Since if statements are so useful, they can actually be a little overwhelming when you get started. This section gives some examples of patterns that can help guide your thinking about using if statements in different ways. They are not exhaustive, since there are many ways to leverage and twist conditionals. But if you treat them as ideas, you may find that they inspire you in different directions. An if statement nested inside of an if statement is equivalent to having both conditions combined with an and statement. The advantage of an and expression is usually brevity, since the code will only take up a single line without an extra indentation. The advantage of the nested if statement, however, is a little more nuanced. Statements can be added before or after the inner if statement, allowing more statements for the first case but not necessarily for the second. You can specify also additional cases behavior by adding in else statements to the inner if statements, if you need to narrow the behavior further in the case where the first condition is true and the second condition is false. There are operations and functions which are valid syntactically but will cause an error in practice. A classic example is division by zero, which causes a zero division error. Using an if statement, you can make sure that a variable such as time is greater than 0, and therefore safe to use for the denominator. As another example, you can use the isDigits method of strings to make sure that the string is all numbers before you try to convert it to a float or an integer. Other common checks include checking the length of the string before you index. The early return pattern is similar to the defensive guard pattern, with an if statement aborting a path before an error can be caused or other undesirable operation. In the example shown here, we check if the message parameter does not have a truthy value. For a string, any non-empty string will be considered truthy. In this case, then, indexing is only attempted if the message is not empty. This is very important, since indexing the last character of the string will cause an index error if the empty string was indexed. The early return prevents that mistake from occurring, allowing us to safely use the logic in the rest of the function to determine what kind of punctuation symbol the last character of the string holds. Parsing code with multiple returns can be a little tricky. What actually gets returned? The key insight to remember is that a function can only return exactly once. That will happen regardless of whether you have a return statement. But if a return statement is encountered, the function is over and whatever value is specified in the return statement is what is brought back to the original call site. That's why having more than one return statement only makes sense when you have if statements. The if statements can disrupt the control flow of the function, branching off different paths for each return statement. For each call to the function, only one path needs to be taken, with only one return statement being activated. In this example, the convert_ordinal function consumes an integer and produces a string representation of the ordinal number, such as first, second, or third. The value stored in number is matched against each of the possibilities in turn, but only one can be true since we are using a mutually exclusive chain of if/elif/else statements. Ultimately, if none of the expressions evaluate to true, then the else block is entered and the value other is returned. A related pattern is the build-up return pattern. How is this different from the multiple return spots pattern? Functionally, they are equivalent. The value being returned is meant to be the same in either pattern. The difference comes in the number of return statements and the exact path that the control flow takes through the program. Some folks try to avoid having multiple return spots in their program, since it is a common source of mistakes in beginner programs. For those struggling with control flow, it can make a lot of sense to avoid trying to mix the confusing branching of if statements with the abrupt finality of return statements. The build-up return pattern can help you isolate the return to a single spot, making it easier to reason about. In the previous convert_ordinal pattern, we had return statements inside of the if statements. But now, there is only one return after all of the conditionals. Instead, assignment statements are used. The end result is still the same though. The else statement is a powerful way to specify default behavior after if and elif statements. But when nesting these statements, the else branch is not always conveniently available. The nested statements represent specific, narrow cases involving multiple conditions. In order to provide a default situation with else statements, every single level of nested if would need to have an else statement, sometimes leading to redundant code. However, the define and refine pattern allows you to specify an initial value for a variable, and then only specify the specific branches to change that value. This pattern is only applicable when you have many default cases that are the same. In this code example, the program is attempting to determine whether the user can sleep in. It must not only be a weekday, but it must also be before noon. However, with the way the code is currently structured, we must provide an else body for each of the conditionals. This is inconvenient since the action to be taken, assigning false to can_sleep_in is the same along both of those paths. The define and refine pattern suggests a solution to clean up this code. In the new version, we first initialize the can_sleep_in variable before we structure the if logic chain. That way, we no longer require any else paths at all. This only works because the behavior was the same along all those paths, though. We couldn't have made this change if either path had different behavior. Granted, both of these programs also ignore the many good people who sleep in past noon, but let us leave them aside for the moment.